This is lesson 7.1, interior angles of polygons. So a polygon is a closed figure formed by three sides or more, three or more line segments called sides. So we have names for different polygons based on how many sides they have. So three sides would be called a triangle. Right? Four sides is a quadrilateral. And then the rest are all sides, like polygon, they're all sides. So five is a pentagon. Six is a hexagon. Seven is a hexagon. Eight is an octagon. Nine is a nonagon. 10 is a decagon. 11, we're just going to call it an 11gon. 12 is a dodecagon. And then any other number that we just call n, we use that n-gon. Kind of always saying the 11 kind of thing, we're going to call an 11gon. There is a name for that. There's a name for all these other things. We just really care about them. So 11 is an 11gon. And any other number like this one, it's just that number. So to find the sum of the interior angle measures, the sum of the measures of the interior angles in any polygon can be determined by the number of triangles that be drawn within the polygon. So let's compute the table and look for the pattern. So a triangle has three sides, and it contains one single triangle. So one triangle is just 180 degrees. A quadrilateral has 1, 2, 3, 4 sides, and it's created two triangles. So two triangles, each one being 180, is 360 degrees. A pentagon has 1, 2, 3, 4, 5 sides. I create 1, 2, 3 triangles, and three triangles each at 180 degrees is 540 degrees. A hexagon has 6 sides. I have 1, 2, 3, 4 triangles, and four triangles each at 180 degrees is 720 degrees. So if I want to come up with a pattern that I'm seeing, 3 sides had 1 triangle, 4 sides had 2, 5 had 3, 6 had 4. Each of these, the number of triangles is actually 2 less than the number of sides. Right? 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, 6 minus 2 is 4. So what we can come up with is that there are always 2 less triangles in sides. So if I want to come up with how many degrees it is, if n is the number of sides, then the sum, or S, equals n minus 2 times 180. You could also write this as 180 times n minus 2 if it looks better to you, right? Because it looks more like what we would distribute normally. But luckily, we won't really be distributing that. That's going to solve the n minus 2 first and then multiply that by 180. So if I wanted to find the sum of the measures of the interior angles of a 15gon, we're going to do 15 minus 2, which is 13. And 13 times 180 is 2,350 degrees. All right, this next one has 1, 2, let's ignore that bell. 3, 4, 5, 6, 7, 8, 9, 10. This is a 10 minus 2 times 180. So 8 times 180 is 1,440 degrees. At 48gon, that's going to be 48 minus 2 times 180. So 46 times 180 is 8,280 degrees. That is huge. All right, this has 1, 2, 3, 4, 5, 6, 7, 8. So an octagon. 8 minus 2 times 180. 6 times 180 is 1,080 degrees. So if we wanted to work backwards, and here it might help us to have it flipped with 180 times n minus 2. If the sum of the measures of the interior angles is 1980, how many sides does it have? So I know the formula is the sum is equal to 180 times n minus 2. I'm going to replace the sum with 1980. If I wanted to, I could just put it here. So we have 1980 equals 180n So I'm going to add 360 to both sides. So now I have 2340 equals 180 n. And if I divide that by 180, n equals 13. So this polygon would have had 13 sides. So you're going to try the next one. The sum of the measures of the interior angles is 5400. How many sides does the polygon have? Pause, and when you're ready to see the answer, hit play. So we get n equals 32. It is a 32-sided figure, a 32 gon. So next I want to solve for x. So I need to know how much these all add up. So before it actually make it equation. So I have 1, 2, 3, 4, 5, 6 sides, which means if I do 6 minus 2 times 180, I get 720 degrees. So that means I now know I'm going to take x plus 118 plus 111 plus 124 plus 115 plus 145 equals 720. So this number is going to change depending on how many sides I feed that. So now if I add together the 118, the 111, the 124, the 115, and the 145, I get 613. So if I do 720 minus 613, I get 107 for x. So you're going to try the next one, figure out how many degrees should be inside the shape, and then solve for x. Pause, and when you're ready to see the answer, hit play. All right, so if it has 4 sides, 4 minus 2 times 180 is 360. So x plus the other 3 angles adds to 360. I get x is 72. All right, we've talked about for equilateral, these both sides are the same. We've also talked about for equiangular, for triangles, if it's automatically equilateral, it's automatically equiangular. They go hand in hand. But for the polygon, not necessarily. You can have a shape that's just equilateral, shape that's just equiangular, and you could have a shape that's both. And when it's both, we actually call it regular. Right? A regular polygon is that it's both equilateral and equiangular. So here we are looking at home plate for a baseball field. We want to determine, is the polygon regular? And then find the measures of angles C and E if it's not. Well, not so it's not regular because I can see these 3 angles are 90, but these 3 are not. Sorry, these 2 are not. So all angles are not congruent, so no. So all angles not congruent. That's for a reason. So for part B, angles C and E are the same, so let's call them both x. We know these are 90, 90, and 90. And we can find out that a 5-sided figure, 5 times 2 minus 180, is 540 degrees. So I'm going to take x plus 90 plus 90 plus 90 equals 540. So 2x plus 270 is 540. 2x equals 270, and x equals 135. So each of those angles, the measure of angle C equals the measure of angle E, equals 135 degrees. All right, exterior angles. So in this picture, exterior angles are supplemented to the adjacent interior angle, right, because they form a linear pair. Let's find the measure of the exterior angle and then figure out what they add up to. So adjacent to 79, the linear pair of 79, 180 minus 79 is 101. Adjacent to 40, 180 minus 40 is 140. And then adjacent to 61, 180 minus 61 is 119. So if I add together 119 plus 101 plus 140, I get 360 degrees. Let's try this one. Next to 76 is 104. Next to 89 is 91. Next to 71 is 109. And next to 124 is 56. So adding together 109 plus 56 plus 104 plus 91, I get 360 degrees. So what can we conclude about the sum of the exterior angle measures? We can conclude that it equals 360. It doesn't matter number of sides. And we'll use n. So no matter what, if it has 3 sides, if it has 100 sides, the exterior angle is 360. So what is the measure of each exterior angle of a regular hexagon? So if we know n is 360 and all of them are the same, the hexagon n is 6, then what I can actually do is 360 divided by 6, because they're all the same. You just divide it. So each angle is actually 60 degrees. All right, so you guys try this one. What is the measure of each exterior angle of a regular 24gon? Pause. When you're ready to see the answer, hit play. All right, so if we do 360 divided by 24, we get 15 degrees. A convex hexagon, so they're not saying regular. A convex hexagon has exterior angles with these measures. What is the measure of the exterior angle at the 6th vertex? So the 6th vertex is x, so that one plus the other 5. Should equal 360 because it always equals 360. So now if I add together these 5 angles, I get x plus 283 is 60. So take that away, we get x is 77 degrees. All right, so this one, very similar to the last one, except instead of saying the last thing was x, it's 5x. So we're still going to add all the ones they give us up and set it equal to 360. That's going to be 5x, 62 plus 35 plus 9, 41 plus 58 equals 360. Now we're going to add 62, 35, 69, 41, and 58. So we get 265. Take it away from 360. 5x equals 95. And if I divide that by 5, x is 19. So you go ahead and try this one. Find the value of x given the exterior angles. Pause. When you're ready to see the answer, hit play. All right, so I add them up to 360, the x plus the 2x plus the 89 plus the 67. That gives us 3x plus 156 is 360. Take away 156, 3x equals 204, and divide by 3, we get x is 68. All right, for our last problem, the trampoline shown is shaped like a regular dodecagon. Remember, dodecagon means n equals 12. We want to find the measure of each interior angle and each exterior angle. So exterior is actually the easy one because we do 360 over 12, and we get 30 degrees. Each interior angle. So what I would do first is I would first find the sum. So the sum, I would do 12 minus 2 times 180. So that's 10 times 180, 1,800. So that's what everything inside adds up to. If I want to know each one, and it's regular, so they're all the same, I could do 1,800 divided by the number of angles or sides there are, which is 12. And when I do that, I get 150 degrees. So anytime I use the word each, I'm going to actually be dividing by n. but I first need to know what it adds up to. Exterior, I already know because it doesn't matter the number size. Interior, I would find that first. And that is 7.1 angle measures in polygons.